No, you...
The computer converts these numbers into impulses that cause sound waves to come directly from a loudspeaker.
Just find the right place in the program, make the appropriate change, and we'll run the whole thing again.
The art of computer graphics is only in its infancy. Only by computer could they be calculated and for the first time pictorially described. The entire musical score accompanying this film was composed on a computer that can produce nearly endless variations of sounds.
Speech is still very complicated. Music is simpler.
To be or not to be? That is the question.
Howdy do. Just make sure we got some audio. Welcome to another one. 51. Number 51, never. 51 3-hour videos or somewhere thereabouts. Never. Let's say they're 2-hour. Let's just make sure we got audio. Make sure we got some audio. Well, we have some audio. So what is it all about today? What on earth merits another video? 51? Basically, I'll show you in a minute and you'll realise, so K40 Whisperer compatible design. Okay. Now I've got a couple of K40 Chinese CNCs. Now they will only cut 320 by about 200, somewhere thereabouts. Got to verify that yet. I've got a brand new one that's never been done anything with other than test. I've got a used one that's got a problem with the laser breaking down after engraving for a while. It starts getting weaker. So anyway, so I want one basically to do, let me just bring on my face, hello face, face on, face off, wax on, wax off. Yes, completely from left field, yeah, I know. What can you do? Could rename the channel from left field or something like that, out of left field. Anyway, it's not supposed to be out of left field, just what it is, I don't know, it's just weird stuff. Anyway, so we'll start off by showing you, I did some milling. Let me show you a little bit of milling footage. Now to get that up, I just need to try to find it, which is not easy considering I need to view it in detail mode because I don't want to play one that I played. It's in detail mode already. Right, okay. Right, let's go down to the videos. Right, here they are. I have no idea which one's the latest one. I think it's date and time stamped. Let's have a look. That's it. There's one. Right, so it's these ones here. Let's start with this one. Right, here we go. I don't know if they're in the right order. Right, I put myself on. So we've got this is milling out one of the panels. Hope you can hear me over the noise. Maybe you can't, maybe you can. Maybe it's echoing, I don't know. Tell you what, I'll turn down the audio from the display capture if I could do it, but I don't know how to do it. Desktop audio, right, let's turn that off. Right, let's mute that. not sure it is muting it actually. No, it's not muting it because it's coming out the speaker. So I could mute it on here. Tell you what. Let's mute it there. Has that muted it? Maybe. Maybe it's still too low. Let's go a bit further. Yeah, hello. Right. Anyway, so this thing, I got the plastic already reclaimed. 6mm acrylic, cast acrylic it is. I bought the new milling bits, which is that there. Pack of 10. They're supposed to not stick to it. They're still sticking to it. That's the milling software, Mac 3 milling software. Now it's still, can you see it sticking to the tip? And I have to keep pausing, whenever it lifts up I have to pause it and get the pipe spanners and crack it until it falls off. Squeeze it basically till it cracks apart. Okay, so anyway, it's you can see what mess it's making. See the bits there, it's lifting the bits up. Right, it's sticking to the tip. Anyway, so it's all this jagged edge. Right, I'll show you the outcome in a minute. The real thing, the amount of rework, and I actually scratched it trying to take the edge off. I scratched the surface trying to tidy the edge up. It's too much work, basically. Even that's been clamped down too tight, and I had to hold it down. Anyway, we'll let it play to the end. I suppose we could skip a bit more. My hand's in the way. Don't do this at home, people. You don't want to do this at home, especially put your hand near it. So don't do what I do what I say. And it's full up. See, the tip is full up of stuck plastic. Look at it. See what I mean? And that is a special milling bit for cutting acrylic. That it's got a special coating on it to avoid all this problem. Anyway, I'll just leave the mouse alone so we can get rid of that. Yeah, get rid of that. I'll let you watch that a minute. So here's a panel that I cut out. This one, every hole you put in it, it's more work you've got to do, rework. You've got to trim up the edge. And when see the holes, there's whiteness around the holes. Now that is the plastic that's stuck to the milling bit being burnt into the top of the plastic, and you got those burrs sticking up. So it's never a good idea. Now I have to go around and trim that up, but as you're trimming them, you stand the chance, whatever tool you use, you could scratch the surface. So that's one. That's that gone. All right, let's find the next one. Alright, next one. This is milling out the pockets. They're in the wrong order, these are. So you can see the tip full up of melted. You can't get it off. You have to crack it to get it off. You have to squeeze it to. It hardens up quickly. So that's done the pockets on the trim. Is this the next one? Oh, looks like the same one. Why is that the same one? Anyway, it didn't mill it all the way through. Let's go to the next one. Oh, what is it doing now? Oh, it's cutting it out. Yeah, sorry. This is the front grille, the air intake. It's milling out going around the outside. It's an outside cut basically, but look at the state of all this. Look at it. See, it is all hard plastic. It's melted and left it like that. Now I have to trim that. You can go around it with a blade or something like a wallpaper scraper or something. And no matter, you can spend hours trying to do it without scratching it, but you're going to scratch the surface. I've scratched it. But that's not sticking to it now. It's okay on fast bits like that, but when you have to hang around, and it gives time for the plastic to stick to the end. I did try changing the speed. I tried to change the speed down a bit, less speed. So this idea was okay, but imagine if this was on a laser machine. They would just cut these out, and you wouldn't. There's no retouching. It's just finished as it is. These just drop out, and you pick it up, and you don't have to rework it. You don't have to trim it. You don't have to tidy it up. You don't have to do nothing. Look at the mess it's making now. And these were supposed to be the right tip. And this is I've slowed this CNC down. I've by 50%. Should be running twice as fast. Maybe it'd be better if it did that. Well, I didn't want to take the chance of breaking the milling bit off. So anyway, I'll speed that up a bit. Look at the state of it. See the lift on it. And the last thing I want to do is sit there for hours doing this. Now I've got 2 laser machines, but they only cut 320 by 200. But I've not used them for this. I'm using my milling machine, my CNC 6040. It's a 600 by 400 minus about 15 mil. So that's hence why I'm using it to cut the panels out. Let's just go back here. Let's get to almost the bit where it's finished. That's showing you the software. Oh, it's just finished there. Hang on, let's just go back a touch. No, it's just finished. Let's go back a little bit more. Right, this is nearly finished. It's got a build-up of plastic on the tip, which is not good because. And see, it's almost solid. I think I stopped the thing turning it. That's just a view of that. End of the G code, and it's clogged up. So I thought if I buy the right milling bit, it would do a better job. It's stuck in because my table's not flat. It's on a bit of wood. It's not flat. The spoil board's not accurate. Yeah, I didn't. It was okay this side, but not the other. What else we got? Let's have a look. I'll just show you these. Right, this is. Don't know what this is. Oh, this is doing the slots. The panel that contains the card slot guides. It's doing some weird stuff. The G code's doing, and it's done that little bit. It's already stuck on. It's already stuck. And it's pocketing out the V. Later on, it'll cut it across there, and it'll get rid of that rounded bit. That's his tool path. So this would do a better job in aluminium, but it would take longer to cut it out. But you'd end up with the fine shavings instead of. And this thing, it's flinging these pieces out everywhere. They're hitting me. They're burning my hands. I've got me protective goggles on because. Stop them going in my eye, but it's chucking them out everywhere. The only reason it chucks it out is when it builds up to such a width, it flings it off. Look, it's just milling with a clogged up bit. It's a waste of plastic. I mean, if this was a new piece of plastic, I'd be crying. But anyway, it's the first off. It's a trial and error. But every time it goes up, I stop the machine. Not on this video. I stop it. I give up trying after a while. I'll stop it, then unclog it, then it'll do another couple of inches and get clogged again. So anyway, let's speed that up. So let's speed it up a bit. It's just cutting out the air vent that goes alongside the card. Oh, there's a nice picture, nice zoomed in one, so we'll play that one. See, all the tips all clogged up. It's just melting it. It's spinning. It's not a cutting. It's just spinning and melting it. Right, so let's get to the next one. Let's hope I haven't got a video of me taking my underpants off. Click it by mistake, anyway. Yeah, so this is cutting out. Actually, this is actually the cutting out this thing. And I've noticed, I did a front panel, I noticed when I hold it up to the real thing, my CD-ROM bay is slightly out. And I can't figure out the life of me why, but we'll have a look at that in a bit. Let's speed this up a bit. You'll see when it comes around the top, it actually cuts across the top of the pockets, so you get a nice angle on it. So I think the way to go is the laser. I'll show you the results anyway. It might not be as bad as I make out, but there's too much work on it to get these edges down. Because this stuff, it goes hard. It's just like hardened plastic. And as it's building up on the tip, it's actually causing the edge to fray, melting the edge and making it worse. Let's get speed up a bit more. Yeah, it's more of the same, just cutting it out till it finishes. I don't think it's finished there. That's finished, so I move it out of the way. Switch off the the inverter that drives the spindle to variable speed. See that brand new bit all stuck up, and it was a real ball. Look at the mess. You have to hoover all that up, and it's a ball ache just cutting the plastic into these 600 by 400 millimeter, well 300 mil panels to go on the table. But there's a finished thing, sort of. The idea is there. But you know, look at the all the stuff that's built up on it. I've got to cut that down. The holes turn into a bit of a mess. All the holes have swirled round the stuff that's stuck to the milling bit and melted it. Right, what else we got? Oh, this is cutting out some of the... What is it cutting out? I don't know. Can't remember now. Speed it up a bit. Oh, these what are these? Oh no, this is doing the front panel. This is doing the floppy bay. This is the double floppy bay on the front panel, and the CD tray and everything. But I must have got my sizes wrong or something. I'll have a look in a minute. Let's speed this up so it cuts that out, and when it's finished it goes loose. But look how frayed it is. Yeah, it's loose now. It's going to cut a bit more G-code because it doesn't know it's cut through it. So I got to try and move out of the way before it jams my bit. And if that gets trapped between the milling bit and the rest of the plastic, it'll break the milling bit off, snap it off. So I have to get it out of the way quick. So I think that's the end of that, and it's about to go and start and do the other one, but I've stopped it there because I'm cleaning up the edge. Right, I've cleaned the tip up now, so then let it carry on. I put a feed hole on it, and it starts off nice till it builds up. Till it builds up with plastic, it gets worse and worse. I've tried altering the speed. I haven't tried it very low speed because I'm worried about it digging in and snapping it off. But this cast acrylic, it melts at such a low temperature. Now I've milled polycarbonate before now, and I'll be able to tap it and all sorts. But this was free basically. It was given to me, and I've got a lot of it. But it reacts well to laser cut. So I think that's the way to go with this particular material. Every time it goes around, this stuff is building up on the edge and melting into the plastic, so they've got even more work to tidy it up. But anyway, there's a problem here because I'll show you in a minute, but that is in the wrong place. That piece is in the wrong place, that cutout. Let's just go a bit faster. Let's just cut it out now. Yeah, it's just doing the last bit. Right, and it goes and cuts the pocket out. I think it might have done all the other bit. Yeah, that's it. Right, that's finished. Let's have a look at the cutting out. Yeah, so it's milled them out, and it's going to cut it out now, which is just around in that oval shape. There's all the bits I've milled out already. Let's just move it along a bit. Right, it's potting the countersunk holes now. This is the 3mm deep pockets so I can tap with an M4 tap. That's all that is. But because my table's not quite flat, it's going as deep as where it thinks it is. Well, you know, you need more accuracy really. It's difficult. Right, so it's just milling the holes. So let's move it along a bit. Oh, and it also milled out. When it milled this pocket out, I was supposed to leave a shoulder on it here, but what happened was because of the depth, it's gone too deep. It cut out the shoulder. It started making a shoulder, which I'll show you in a minute when I get to that bit. So that it balls that up basically. But it's all right for you know, to test, to make sure you got other measurements right. So you build it. Look what it's done to that hole. See that hole there? Look at the stuff's burnt all around the. So that's, look. There's no way to get that off. It's done it to these. It's not good. Anyway, and I butchered it basically trying to get it flat. I scratched it all over and everything. I think it'd be okay. You could lightly sand it or polish it or sand it and spray paint it maybe. This is just cutting out the panel. Speed it up a bit. So it's just cutting out the panel. So the G code's there. It's just yeah. Let's just speed it up a bit more. Well, that's it. Yeah, it's not. I don't think it's actually loose as well. It's loose to one end, but this end's low. It's something to do with me clamping it down as well. It's bowing the material. You need a vacuum table really. It needs to be sucked down on a vacuum table, and you can get rid of all the clamps. But then you have to run a vacuum cleaner or a pump to suck it down, as well as a vacuum sucking up the bits. So it's really rough. And look at the tip clogged up again. And you can't get it off. You have to crush it to get it off, which is not a good idea. Anyway, so there's that. Oh, there's the finished thing. Finished as in cut out. It needs loads more work. It's an awful state. A state of it. But if that was done with a laser, it would just be, you wouldn't have to touch it. It'd be spot on as it was. There's a bit of aluminium there, because I've milled out aluminium on some of my old videos. Right, next one. This is the last one. No, it's not. That's something else. Not me in my underpants though. Right, so that's that. So let's show you the actual thing then. Let's show you that. Right, yeah. So unfortunately, I haven't had a shave, so never mind. Right, what have we got? Let's show you. Right, so I'll show you this bit. This is not really. This is the milling. You got the problem. So you milled out the flat. This is the vent grill, which is that way up, I think. Yeah, that way up. That sits under the just like that, where the vents are. And if you look closely, it's horrible. It's all scratched. Hang on, can you see it? Can't see it. It's basically one side will be fine. You have to trim it with a knife. You know, it's all milky and horrible. Yes, you can put a hot flame on it and bring it back a bit. It might be worth a try. It might make it worse. Anyway, it's just turned out horrible. It can't. I don't think it does it justice. See all the scratches up here. There, see all the scratches where I'm trying to get this stuff down. So anyway, it'll be alright for a prototype, just to see what it's like. So then there was these things, the spacers, milled out the spacers. I haven't touched these. I haven't cleaned these up. There's a burr on them. Can you see the burr on them? Horrible burr. Anyway, and yeah, there's bits sticking out, bits of this stuff. It's so hard, I can't get it off. I've just got it off then. But these will stack up like that, the spacers, and they're a bit thin. They're a bit thin, but that's to space the front out. Not very good. And then you got 3 of the smaller ones. Just the smaller ones again. Right, then we've got this panel. This one with the card slot, so that way round you'd see the keyboard and the mouse and the shoulders. But this one's probably about the best. I ended up scratching it. Can you see the scratches on it? Don't know if you can see it from that side. Lots of scratches. It's hard to see the scratches. Anyway, it probably looks better than what it really is. I mean, once it's in there, you won't see it, but that's not the point. Anyway, so there's a hole that went funny. It's all gone white, so it's melted the hole on that one. So, yes, it'll work, and something went weird there. The corner got milled out there. Anyway, there's that. What else we got? Here's the card slot piece. This is probably the worst. This is the worst. Look at all the white stuff still left on it. And I resorted to scraping it with a scraper. Look at all the scratches. I was just scraping it like that, trying to get this off. But it's melted into the plastic. It's actually, it's sort of level. It is level, so it can't chisel any more out. But it's all scratched here. I lost my patience with it, and right. So don't know if you can see it. It's a bit of a, see all the scratches on it. Then they weren't scratched before. It's me scraping at it. Well, it proves the idea. There's still a bit there. There's still a bit of rubbish left on that one. Look at that. Right, so that's that. Right, so the front panel. Front panel. This took hours. This did as well. This one, I got so fed up. I haven't even trimmed this one off. This one's not even been trimmed because it hadn't done the shoulder right. There was supposed to be a shoulder in there, so the bed was out like that, and it's well, it's milled too deep, and again it's scuffed up the hole there. Look. And this is in the wrong place, believe it or not. This piece here, it's in the wrong. It needs to be shifted over. So I don't know what went wrong there, but we can alter the design of that. And that's the edge. That's the edge of it. Still full of the burr. Here's the burr. It's just dropping all over the place. Yeah. So anyway, there's that. That was going to be out of beige. Anyway, so the design is there. What else we got? Is that the lot? Yeah, I think that was it. Yeah, that's it on that. So anyway, let's go back over to this other one. So, to that end, I don't know if anyone knows what a K40. K40 is a Chinese CNC laser machine. Let's just bring one up for you a minute. K40 laser engraver images. Right. So let's just go back over there. Yeah. So these are the Chinese K40 laser engrave. Now the first one I bought was like one of these, second hand. Then I bought one like, you can't see it here, a grey version of it, so an updated version of it, similar to that. It's probably it, that one. So that one's brand new, but they still only do, if you Google the cutting area, right, it's 8 inches, so 200 by 300 it says. So yeah, I think you can get 320 out of it. Real cutting area out of the box. So what's this one saying? Usable area 328 by 213. Right. So let's just say it's 300 by 200. Yeah, let's just say it's 300 by 200. Right, let's get back out of here. Anyway, to that end, let's go over to the model. So what I'm trying to do now is I'll keep the plastics as they are, but create a... I need to chop it up, basically. I need to be able to make this on... I need to be able to make this on the machine I got. I don't want to go and spend a couple of £1,000 on a bigger machine that you can cut this out in one piece. It'd be nice to be able to do it, but the problem is it's having the space for anything bigger. I haven't got the space for the ones I got. Never mind for anything bigger. So, and to that end, some of this stuff. Now the main problem is this bit here. That seems to want to be in one, doesn't it? If I remove the front cover. Now this in. Let's remove the lid a minute. Get rid of the lid a minute, right? So, and let's get rid of the drive assembly. If I can find it. Where are they? Can't see it. Yeah, move that. So if you look at the plastics, we've already got these two pieces. Hang on, it's probably best to go into this mode to have a look at it. So these two pieces these three pieces are separate pieces, right? And then you've got this piece. So those four pieces can be made on the K40. Probably using the K40 Whisperer software. I'll talk about that in a minute. So this rear panel, it's basically you could make it in two, couldn't you? You could make it in two. So we'd have to have an extra fixing. We've got four fixings anyway. So we could probably move one over a bit and the other one and split this into half. This back panel. Somehow split it into half. Now where we do that, I don't know. And if with a bit of ingenious design on the back plate here, ideally we could extend this bit or do something where it sandwiches the two pieces of the back plate together. So as you bolt it through, you'll have to have more fixings. That's the only thing. But that acts in two ways. It's a shelf and a bracing plate to brace the back two together to stop it shearing action. So that could take care of that. So that could be done pretty easy. Now let's have a look at the base plates. Now the base plates, they're already in 4 sections. So we'd have to try and devise a method of what to do it in. Now it's in 4 sections, partly to give you strength laminated effect of strength. Let's go back to this other mode for this. So the one laps over the other, so when they're bound together it gives you some strength. So it's automatically, it's like a bracing action all in itself anyway. It gives a bit of weight to it as well. So yeah, it's a waste of plastic, and plastic is dear. So really, just they had it for free, and I got lots of it. So, but if you have to buy it again, a sheet, you're looking at expensive, very expensive, just to buy the materials. Never mind to make anything. So anyway, I would have to somehow make this. They'd have to be made like that and bind them together somehow. Now, if they're going to be laser cut, it's not easy to do pocketing. So you either cut it all the way through. I went on ChatGPT and I says, can you laser cut? Can you pocket with a laser cutter? She says you can, but you know, you have to alter the power level so you don't cut all the way through it. But then you've got multiple. It's such a thin thing, 0.1 or 0.2 of a millimeter beam. You'd have to do so many cuts backward and forward like that just to get it to a pocket, and it might leave bits. I'm not sure. It might not come out flat. Like milling it, you know, you can go along with a fly mill. You can cut it flat. Anyway, so we're gonna have to design something. I'll tell you what. Let me just say that. Let me bring up an old design. Because I was constrained for size-wise, not as in what could be mill, but what material I'd got to use. I had narrow strips of material. So if I just go into here a minute, and if I can find it. Oh, hang on. There it is. Right. I don't know if this is the latest one, but yeah. So I made this. This is probably one of the old designs, is it? No, it is the new one. I made this for the missus. It's an embroidery reel carousel. So I designed this. I put the spools on. Basically, it's made out of laminate flooring, leftover laminate flooring. So there's your laminate floor piece, typical size. Now, in order to get a circle, you know, an area that big, I had to bolt it to the underlying. Make this circular bit here. Hang on, spaces, spools, reels. Yeah, so they got dowels in there. I had to make this circle here, which I could cut out of the same material, and then let you bolt it to that. And that's how I did it. Even milled out the spaces. Anyway, so you can make bigger stuff out of that. That's an old design. That's some G code there. It's like a model village, this, isn't it? One of the first designs. I didn't go with that one in the end. Anyway, oh, it even tells you what the cutting list look. Right, let's get back to it. So anyway, you can do stuff with it. Now, for instance, I'd have to join up. So if I milled out squares, no, laser cut squares like this size, for instance, then we could have a square around here that you stitched it together with. But then it's going to look a bit horrible. Let's hide the PCB a minute. Right. So, obviously, at the minute we've got two layers. We've got one running that way, and the other two running down that way, and they're bound together with these stitches. And they're square, so it doesn't look a problem there. what I've got to try and work out is how to do it. How to stitch 4 of them together. So you could put a square in and it could sit under the PCB. Then you'd have to have bigger pillars. It's too much compromise, isn't it? It's too much compromise. So unless so yeah, the funny thing is I never had so much trouble with these when I was using the wrong milling bit. I bought the right one and it's worse. I don't understand it. Yeah, it wasn't too bad. I had better results with the wrong bit. So I don't know. It's a weird one. But some people say you've got to get water in a squirty bottle, put it in the fridge, and then keep cooling the plastic down. Even put the plastics in a freezer, bring them out cold, so it stops them getting hot enough, so it cuts it instead of melts it. Don't know. Anyway, that's a lot of aggro. So I think everything's got its pros and cons. The pros and cons. The pros are with laser in it, you haven't got to touch it, and there's no chance of the milling bit hitting it and messing your work up. The cons are you can't do pockets easily, probably, and you've got to somehow, with a smaller size, stitch it up. Anyway, leave the base out of it. Whatever we do with the base, we've got to do with the lid as well. So the same thing will happen to the lid. Now I was thinking on the top you could stitch it with a round plate, couldn't you, and sit your monitor on a round thing. No, silly idea, but yeah, a bit like a platter. Or you could put the round piece or the stitching bit underneath. But what you don't want to do really is what you need to do is overlap it. I don't know. Unless we do a crossbow type of thing. So you put the plastics, lie the first lot of plastics down, and then we make a strip. We mill out a strip that goes across them two. You know, you so basically, yeah, so you need to tie that up. So these would be, you know, you'd have to create like a flat panel that go to there, but then you still got to stitch it up in the middle. So you'd have to start off, you'd have to almost do something like this, have a piece you can cut out there like that. Then you'd have to probably have another bit here like that, and another one over here like that. And then you'd probably have to do another one here like that, and so forth, similar to that. So you'd bolt this, use the same stitches to bolt it together. And your PCB, and obviously might have to use bigger standoffs, maybe. Unless your standoffs were on top of these. Yeah, so anyway, we're just running ideas through it. So there might be a way of doing it where it doesn't look too bad, or if you're going to stitch them together, so you'd use them and you'd get rid of the extra piece. You'd use a bit less plastic, or we make some aluminium pieces, mill out some aluminium pieces. Yeah, because I can mill out the aluminium, but I mean, the idea is for anyone who's got a K40 Chinese laser, they can make it. They might not have a milling machine or a CNC router. So anyway, that's just some weird ideas. Let's just go Let's go back a few steps, clear that up. Right, so the same thing can be applied to the lid. Okay, now let's take the lid off a minute. Let's have a look at the front now. So this bit can be done the same way. We could do some of that. We could put an intermediate bit or something here. These turned out too small as well, these did. By the time it was milled, it was just too small. They need to be bigger, really, if we go down that route, unless it's too fiddly. Maybe it's better to do it a different way. Make this in one, you know, fill it out. I don't know. It's one thing designing it, it's another thing actually building it. So anyway, this piece could be cut there in the middle, so that can be made in two parts. Almost, you almost want it like a zigzag. You want like an overlap, but like I say, you can't overlap easy. So to that end, how do we join the two pieces? We'll have to work out how we're going to somehow. It needs to plug together somehow. Unless you could do it like a jigsaw, I suppose. You could put like a jigsaw, like a mortise and tenon joint, or a jigsaw, and then you just super glue it, but then it look horrible. Yeah, so we've got to work that out. Right, so that's one little bit of trim, but then we've got to work out also. So on the front, we've got this. There's no, actually these both pieces are in one piece, aren't they? But it wouldn't take much to, hang on, I've lost it now. Where's it gone? The back panel's on. So that could be one piece, and this could be another. But then you've got to join it. You'll have to join them together somehow. So you could join it from this side, perhaps. Well, because I've got two the same here almost. You could have one. Now they occupy the same space, aren't they? Yeah. So they're held with that pin together there. Right, they're held with that pin. I'll do it from this one. So they're held with a pin together. So these cross members could. Oh, we have to cut them in bits as well. So it's a bit of an awkward one. How we do it. So I want to keep the design together like this. So I'll probably, as soon as you save one design and leave it and go to another, it's almost unusable, because the first one will be unusable. Because any additions, changes you make to the new one, you've got to go then apply it to the old one, or if you don't, it'll be out of sync. And really, you'll never touch that one again anyway, so you might as well get rid of it or modify the new one. But I do want to design this out aluminium as well, to make a new one out of aluminium, thin aluminium, very thin aluminium. I found a piece of aluminium today at our works, and I took a picture of the label, and it'd probably be okay. It's still got that there, look. It's not the motherboard, is it? That's alright. Okay. That's the compact flash. So basically cutting it apart is not the problem, it's putting it back together. So making the separate parts, somehow you've got to stitch it. And it's got to be strong enough to be able to be moved around. It's just a shame that it's so big. You know, if you did a smaller computer, it would be much easier, but, you know, if it was like half the size. It's sort of damned if you do, damned if you don't type of thing. Stuck. So, I suppose, what about 3D printing the whole thing out? Use a lot of plastic, wouldn't it? But 3D print the whole, each section. I've got a 3D printer, I've never set it up, it's just it's a cheap one. So, and you use a lot of PLA, but you wouldn't have the mess, but it'd take you hours to... It would just take you literally hours to, to do the business. I'm just going to have a pill. Yeah. So, excuse me, I just want to, how am I going to do it, I wonder. Got design in sections or lay out money for a bigger CNC laser. And the problem is, we want other people to be able to make it. So, not everyone's got a big laser. Not everyone's got a laser at all. So, I don't know. See, you can make certain parts. These three here you can make. So you can make these three. And because we're going to build this up out of bits like this, stitched together, that was the whole idea. So I'm just trying to work out if there's an ingenious way of doing it. Tell you what, we'll ask ChatGPT. Let's see if it can work anything out. I'm going to ask ChatGPT, see if it knows how to do something. I have a SketchUp model of a AMIGA 2000 case. The I use Sketch cam flat script to generate the G code for my CNC 6040 router. I want to use a Chinese K40 laser engraver instead, but I will have to cut up the panels into smaller parts, i.e. 500mm by 200mm panel into two 250 by 200 panels in order to get them to fit the K40 usable laser area. I need a good idea on how to join the two parts back together by simply bolting them together with M4 bolts, nuts and bolts, nuts and bolts. Could you suggest a great way to do this? It needs to be as low profile as possible and needs to be made from 6mm clear cast acrylic. Alright, let's see what it comes up with. To join two parts of 6mm clear cast acrylic into a low profile efficient way, there are several methods you can consider. Here's an idea that combines simplicity, strength and clean appearance for your K40 laser engraver projects. Acrylic joints with interlocking finger joints or dovetail joints. These interlocking joints are ideal for creating a seamless low profile connection, and they work great with laser cutters because they're easy to design and cut. Here's how you could approach it. Design the joints, design interlocking finger joints or dovetail joints on the edges of the panels you want to connect. These joints are made up of matching interlocking shapes that fit together snugly. Create slots. You can add small slots or tabs on each panel's edge to slot the piece together. This design will also help the alignment during assembly. Slots, right, okay. Laser cutting. Have the finger joints cut precisely into acrylic panels with your laser engraver. The precision of the laser cut ensures the parts will fit tightly together. Glue for reinforcement. After fitting the parts together, apply a small amount of acrylic cement or solvent-based glue for acrylic to the joints for adding strength. The glue will bond the acrylic permanently without visible seams. Right. Okay, maybe. Acrylic dowel pins. This method involves using small acrylic dowels or pins that fit into holes on both panels, holding them together. Drill holes. On the joining edge of the two panels, drill small holes of a specific diameter that correspond to the diameter of the acrylic dowel you plan to use. Insert the dowels. Cut short dowels from clear area, low profile. The dowels can be designed to be flush with the acrylic surface or recessed slightly for more. Glue optional. T-slot joining system. A T-slot joining system involves creating a groove along the edge of each panel that can hold a separate connector piece. These are widely used in assembly systems that can work very well for joining acrylic panels. Create a T-slot on the edge of your panels. Use the laser cut to create a shallow T-shaped slot. Use a T-slot connector. You can design a simple T-slot connector that slides into the slot on both pieces, and when pressed together, connector holds the panels firmly. Right, alignment and strength. The T-slot keeps the panels aligned while also allowing easy assembly and disassembly for a clean look. Make the connector as thin as possible. How do I mill out a T-slot? How can you laser out a T-slot? I don't know how you can do that. Invisible butt joints with acrylic welds, right. If you're looking for a seamless look with minimal profile, you can use a butt joint method combined with acrylic welding. Prepare edges. Cut the edges of the acrylic panels so that they meet cleanly and align perfectly. Weld the joints using acrylic welding solvent, which slightly melts the acrylic and bonds the parts together. You can glue the edges together seamlessly. When done correctly, the weld is almost invisible. Right. Reinforce the acrylic. Reinforce with clear acrylic rods. Acrylic angle brackets. If you're okay with a small visible profile, you can use custom cut acrylic angle brackets for the connection. Cut angle brackets. Design small angle brackets L-shaped from acrylic and then cut them with your laser cutter. These brackets will be positioned inside the corners where the panels meet. Attach this with screws or glue. Use small screws, M4 or small, to attach the brackets or glue them in place. The acrylic is thick enough to hold screws without cracking. Using acrylic cement will help. Minimal visibility. Choosing clear acrylic for the brackets. They also blend into the panels, creating a subtle but strong connection. Final thoughts. Finger joint method would be ideal for a low profile, strong and clean solution, especially since you're working with clear cast acrylic. It eliminates the need for visible fasteners, resulting in a more professional, seamless look. Plus it's easy to cut on your K40 laser engraver, will not require additional materials. Right. So, yeah, there's a few things. On a related subject, I purchased 10 2 fluted upcut milling bits that were coated blue. Supposed to be okay, I'll have an extra P then, go on. Supposed to be for acrylic, but whatever speed I ran the CNC router at, the acrylic stuck. Acrylic waste stuck to the bit and had to crush Crush the stuck acrylic. To get it off the bit. Can you suggest where I went wrong? Sounds like you're encountering an issue with the acrylic is melting or fusing to the cutter during the milling process, which can be quite frustrating. Yeah, it can. When milling acrylic, a few factors can cause this kind of problem, such as speed, feed rate, tool choice, cooling methods. Here's a breakdown of potential causes. Cutting speed and feed rate. Spindle speed, RPM. If your spindle speed is too high, it can cause the acrylic to heat up too much, leading to melting and sticking to the bit. Acrylic has a low melting point and is sensitive to excessive heat. Solution: reduce your spindle speed to around 12,000 to 8,000 RPM. Some CNC rotors run at 20,000 RPM or higher. For acrylic, it's better to go lower. Better to go lower, especially if you're using 2 flute bits. Feed rate: if your feed rate is too slow, but the bit can linger too long in the material, generating heat, that causes the acrylic to melt. On the other hand, if it's too fast, the bit might not cut cleanly. Start with a moderate feed rate. Example: try a feed rate between 800 to 1200 millimeters. This can vary depending on your specific CNC, but it's a good starting point. You may need to adjust based on trial and error. Tool type and coating. Upcut versus downcut bits. The fact that your bits are upcut could be part of the issue. Upcut bits pull the material up, which can lead to heat build up at the cutting surface and cause melting. While upcut bits are great for removing material efficiently, they may not be ideal for acrylic unless combined with the right speeds and cooling. Right, okay, now I know. Solution: downcut bits are often preferred for acrylic because they push the material down, reducing the chances of heat build-up and helping to keep the material from lifting or melting. Blue coated on bits. The blue coating on your bits likely indicates they are coated for durability, often tie-in, whatever. However, this coating might cause more heat to be retained at the cutting surface, especially if the speed or feed rates aren't optimized for acrylic. Solution: ensure you're running at appropriate speed and feed rate for the type of coating. Sometimes switching to uncoated bits for acrylic can help, as they don't retain heat as much as coated bits. Right, okay, that's probably what it is then. Cooling and chip removal. Lack of cooling. Acrylic tends to melt and fuse when it's too hot, and that's often what happens when the chips don't have chance to clear properly from the bit. Proper cooling is essential. Solution: use air blasts, vacuum systems, or liquid cooling. If your CNC supports it, it keeps the cutting area cool. This helps to blow the acrylic chips away, preventing them from melting and sticking to the bit. Chip removal. Acrylic creates long, stringy chips when cut, so make sure you're clearing the chips regularly. If chips are left in place, they can cause heat. Depth of cut. Excessive depth per pass. If you're cutting too deep per pass, this can increase the heat build-up. Acrylic is more prone to melting than large amounts of material are being removed. So reduce the depth of cut per pass around 1 to 2 millimeters. Well, I was on 1.5 millimeters. If the bit is going too deep at once, it creates more friction. Material quality. Acrylic type. Some acrylics, especially cast acrylic, behave differently than others. Like extruded acrylic, when cut, cast acrylic is generally easy to cut, while extruded acrylic can be more prone to melting. Well, maybe it's extruded acrylic then I've got. Solution: if you're using extruded acrylic, consider switching to cast acrylic. It tends to cut more clean, it doesn't melt. I must have extruded acrylic then instead of, I thought it was cast acrylic. Not knowing where its origins as reclaimed material. Final bit consideration: bit geometry. The geometry of the bit, particularly the flute design, is also essential for cutting acrylic bit with high helix angle are often better, provide better chip removal. That's what I've got. Consider using single flute bits or bits with a more aggressive rake angle for acrylic. Right. Summary. Okay, so that's that then. My previous question: which solution do you prefer? Based on our previous question about milling acrylic with your CNC router. No, that's not the question. No, the first question. Apologies for the confusion. First question regarding joining 2 6mm clear cast acrylic panels for your AMIGA 2000K. Ensuring that the low profile and sturdy, I would recommend the following. Best salute: interlocking finger joints or dovetail joints. This is the best solution. Low profile finger joints, very clean, strong and secure, clean and professional look, laser friendly. How to implement the solution: use a CAD software SketchUp to design interlocking finger joints. For finger lock joints, create a series of cut the panels with a K40. Export the design. Edges of the panels will be tapered. Right. The finger joints, create a series of evenly spaced these. For dovetails, make them dovetail. That's an idea, isn't it? Yeah. Actually, a proper dovetail triangle toroidal thing instead of just straight. Then they will lock together, won't they? A tiny bit of glue, that is a good idea. Yeah, interlocking. You don't have to make them loads of them like in the wooden drawer. You could just put longer ones in. Right, glue the joints after aligning. Yeah, I like that idea. Well, Mr. Chat GPT, I thank you. I will go with the dovetail joints as you suggest. You're very welcome. I'm glad the dovetail joint solution works for you. Well, I don't know yet. Should give you a project professional and clean finish, especially the clear acrylic. If you need any help, best of luck with your AMIGA. Right, are you able to produce G-code? Yes, I can help generate G-code if you have specific design or shape. Can assist in creating G-code, material, tool specifics. Right. Okay. Thanks. Right, okay, let's get rid of that now. Let's get rid of that and that. Let's have a quick look at the software that goes with your K40 Whisperer or your K40 Chinese, which I've got. So I did use this a while back, and it's got some newer versions on it now. What's all this about? Ads. So it's got a new version, and it works. Should work with my K40. So we'll probably use that software. I've left a link to this software in the bottom of the description, I think. Let me just make sure. Yes, it's the last link in there. Alright, so anyway, let's get rid of that a minute. So we'll go over to this model. Let's take a couple of pieces. So what we've got to work out where we're going to join this, and let's create a bit of a dovetail. Let's see. So let's just take a bit of plastic. Say make it 100, 200 by 100. Right. Then we'll make it the right thickness. 6 mil. Right. We want a dovetail joint in it. So we'll put we'll come back. We need to go down, interlocking. It needs to go in enough just to, I'll just say 15 mil. Is that too much? 15 mil. So I'll go 15 mil. And we'll cut this up into, I wonder if I could do this. If I say 15 millimeter, can I do times 20? No, it doesn't do that. It's alright, I thought I could get it to reproduce it. So let's just do it manually then. I'll tell you what, let's go more than 15 mil. Let's go 25 millimeter or 30 millimeter. Let's do 30 millimeter. So we'll go like this, 30 millimeter, 30 millimeter. Okay, so we've got 30 millimeter. So what we want, I need to look at this from above really. And probably in parallel projection. Alright, so we're a little bit off center. Let's just do a design. So we don't want to do so tell you what we'll do, we'll make another line here, another 15 millimeter. Alright, and possibly one more. Let's do another one. Right, so that's our center line there. So I'll put a line across there. Okay, so we need to generate a dovetail. So this one section, well, we'll say that's a section. We want to start from and work out. So we need it to cut. We need this piece to lock into that piece, and that piece to lock into this piece. Just gonna have a sip on this drink, so I'm very thirsty. So yeah, because you could slide the two dovetails together, the two pieces, and they'd lock in position. And they might not even need any glue, and you won't need to strap them down. It might be just a tight fit with a laser cut, you know. Let's just have a look. So we'd start from somewhere. So let's just pretend. Let's just draw something like this. See what happens. Okay. So what we want is another line in between. Let's put another line. I think we need another 2 lines, don't we? So that's 30 mil. So 15. So let's do 10 mil and 10 mil. Okay, let's try that. Let's have a look. So we want to come. It's got to go into that bit, hasn't it? So they're going to have to be jointed. So right, so we're going to start. So let's say it's difficult. Yeah, let's say we go to there, and there to there, like that. And this piece, how do you do that? Let's just let's go from there. We've already got that there. Go like this. No, that wouldn't work. Hang on. What am I doing? I should have gone to woodwork class. Oh my god. Can't visit this. Can't what do you call it? So that's gonna be like that. This is gonna be, that's it. That's that one section. Like that. So that sticks out. Now these other bits got to stick in, hasn't it? So we need to get rid of the line. Get rid of the line a minute. Like that. Then we need the same thing this side. So we need another 10mm there. And so let's say another 10mm this way. Then we need that would have to be sort of like that, for instance. That would be like that. Don't know. So that's part of that plastic sits into this, and this one sits into that. That's it. Okay. So then we go. What size is that? 30mm. So draw a line out this way. 30mm. Then we go up like that. It's not easy to do that, so let's put some more lines in it. We don't know what size that is, do we? Hang on. 10mm, so go 10mm. Draw a line here up to there. That's it. So then it's more of the same. Now we've got this piece here that's only 10mm. It could snap off. Just don't like the idea of that. So let's move the whole thing over. $10mm. Once we've got the wider area, let's move this area over. Oops. Let's move this over 10mm. So we've got a 20mm area that hooks in. Now it's going to have to laser cut it. So we get rid of that and that. So we've got this piece here. So it should be able to copy those and move it to, copy it over to there, and again copy it over to there. Right. Let's get rid of some of this stuff now. Whoops, wrong one. Is it long enough to meet each other? Right, so that doesn't belong there. Let's just, yeah, so that needs to then go like that. So we've got this piece, so that's part of this. It's quite angled, so. But you've got to have the same angle, otherwise it won't fit in. So you'd have 2 bits. Let's make this into 2 bits then. Right, let's make that into 2 bits. Cut. No, just got rid of it all. Undo cut. Right, so how are we going to make this into 2 bits? So copy it like that. Copy. Why did it copy that bit? No. That's weird, isn't it? So we copy it. Tell you what, let's copy the whole thing. Copy it. Let's paste it over here. Let's make it into a component. Create a component. Let's get rid of one of these. Let's get rid of this one a minute. Oh, getting rid of the blooming. Gotta be careful I don't select the other drawing. Oh dear, I can't get to it. Can't get to it in this mode. Right. Let's get rid of that. Right, let's get rid of this bit. Extrude it down to nothing. That's it. Extrude that down to nothing. That's it. Okay, so you've got this weird looking thing. Let's make it into a component. Great, so we'll copy it. We'll spin it round. And we'll drag it over here. Let's zoom into this a minute. Let's put it up at the same height. Let's just connect it to there like that. So we've joined 2 together. We've joined 2 together and it's a push fit. And it's laser cut, not CNC'd. Not CNC milled, it's laser cut. It's not. So they're going to be accurate. And it'll allow. Maybe it's going to be too tight a fit. But we could make that, we could mill that out with a bit of plastic. I could put it in my CNC, a single piece. And the good thing is, when you CNC it, the bit that's left over can be used, but you can only get one at a time. So, right, okay. So I like the idea of that. Let me just ask ChatGPT something. One more thing. Dovetailing acrylic 6mm. 2 panels together. Is there an angle and spacing that is preferred? When dovetailing 2 6mm acrylic panels together, there's a few important considerations regarding the angle and spacing. Ensure strong, precise. Here's a guide. Preferred angle typically dovetail angle is around 7 degrees to 10 degrees. This allows for a tight fit while also providing secure mechanical bond. The steeper the angle, the stronger the joint, but it may be too hard to achieve precisely in acrylic. The spacing between dovetails should be relatively uniform to ensure a clean, strong joint. A common recommend is about 1 to 2 times the material thickness for spacing. For 6mm acrylic, this would suggest a spacing of 6 to 12mm between the dovetail joints. Pin width. The width of individual pins, the part that will fit into the corresponding, should also be proportional to the thickness of the acrylic. Typically a pin width around 3 to 4mm works well for acrylic. Cutting methods: use a laser, glue and bonding. So I've done something else. What have I done? Hang on. I've done 40mm and 40mm, and I've gone over 10mm, and I've gone up 15mm. Right. I designed mine 40mm spacing with dovetails that lock with the other piece uh, 15mm, and the locking is 10mm, 10mm. In order to have less joints, could you analyze I can't spell. Analyze this. Could you analyze this? That'll do. I don't know. Let's break down your design. 40mm space between dovetail, 50mm dovetail length, locking area, 10mm locking distance. How far? Pros: the wide spacing will reduce the number of joints, as you mentioned, which can create a cleaner look and fewer cuts. It also minimises the chance of weakening the acrylic by concentrating the stress on fewer points. If the joint doesn't carry heavy load, this should work fine. Cons: the wider spacing might result in a less rigid connection. The further apart the dovetails are, the less effective they will be at resisting shear forces. If the joint will bear heavy loads or if precision is crucial, you might want to reduce the spacing to strengthen the connection. Dovetail length. A 50mm dovetail length should provide a strong mechanic, especially when combined with a 10mm locking area. The longer dovetail helps create a solid joint by increasing the surface area for bond. Cons: the length of 50mm is quite substantial relative to the thickness of the acrylic. The longer the dovetail, the more material you will need to cut away, which could affect the overall structural integrity of the panel if not done properly. Right, fair play. The cut should be precise to avoid cracking or weakening the acrylic. Yeah, got you, I understand. Locking distance. A 10mm lock distance ensures a fairly deep interlock, which is great for ensuring the joint holds well under stress. and offers a firm mechanical connection. This deep depth, especially with the 50mm, should provide tight and strong joint. Cons: 10mm may seem secure. The overall strength of the lock will depend on the material properties of the acrylic. If the locking area is too deep, it might be difficult to align or assemble, particularly if you are using hand tools or machine that requires high precision. Overall strength of the joint is likely to be sufficient for moderate loads. Fewer joints and larger spacing between give a cleaner, more minimalistic appearance. However, the wide spacing could make it slightly more challenging. Suggestions for improvement: reduce the spacing if possible. Consider reducing the spacing. Adjust the locking distance. Material is cut cleanly. Could you suggest the best sizes? Based on original design considerations, recommending spacing 20mm to 25. This range reduces the amount of dovetail locking area. Spacing between. Why this structural size? Either assembly aesthetics. Right. Let's try and make sense of that. Where's the final recommended spacing between the dovetails? 20mm to 25. Right, let's do that then. Now, is it between these dovetails it's on a bit, or that bit? I don't know what it's saying. The spacing between the I tell you what, can you draw me a example with characters, please? I can't spell for the life of me. Characters. Sure, as an example with this, right, the dovetail, right. Panels ask if show two panels with 20mm spacing. Right, so the dovetail shows this. What shows one side of the dovetail cut? Shows the matching dovetail on the other. There's nothing different, is there? Can you show them two pieces of material connected with three dovetails each? What the hell is this? They're all the same. What's the left side? Oh, hang on. There's more. That's all the same, isn't it? I need to see them interlocking. Oh, that's not interlocking. No, it's not working. when interlocking. There's nothing happening. It's all the same stuff. I need sizes on the dovetails. Is it just going to give me the sizes? Right, what's it doing? Come on, ChatGPT. Right, 3mm pins, 20mm spacing. I think it's getting confused. Can you draw it in another way, like 2D? What the hell is it doing now? It's confused, isn't it? It doesn't know what I'm talking about. Just show the two pieces locked together. 2D view. It's just going round in circles. It can do this sometimes, and it's probably because I've exceeded my allotment. So it's using the old ChatGPT now. Get smart responses. Upload files and images and more. What? Right, okay. Log in, sign up. Don't know. Yeah, it's not good. Right, let's try and work it out. It's not going to tell me the thing I want to know. Pin width 3mm. The vertical width of the dovetail pin that fits into the tail of the other panel. In this case, each pin is 3mm wide. Dovetail length. The length of the angled portion of the dovetail. A slanted cut extends 12 meters down from the top to the panel. 20mm spacing between the center of each dovetail pair. Each pair of dovetails spaced 20mm apart. Locking depth. This is the depth of the interlocking portion if it's not explicitly shown. Right. I'm confused. It's not helping, is it? Hang on. 3mm, 12mm. You're dealing with someone who's thick here, mate. So I'm thick. 12mm length angle, 3mm, 20mm. Right, let's so 3mm by 12 by 20mm spacing. Okay, let's try that then. 3mm by 12 by 20. Let's just draw something else. So let's just draw this line. How can we do it? Don't know what I'm doing. 3mm. 12. 12. What angle though? 7 degrees. 12. Did it say 7 degrees? 7 degrees. Oh, is it it's moved the whole thing, hasn't it? I didn't tell it to rotate that. Seven degrees. Okay, so that's 7. Then what was the other one? 12mm spacing. 12mm, then 20mm spacing. Okay, 20mm spacing. Oh, what's it done that for? My fault. 20mm spacing. Then we want something like that again. Flip it. Flip along the red direction. Right. So that's a lot, isn't it? 33 mil. 20 mil. Oh, I'm confused. Isn't that what I've got already? Can you explain as a SketchUp explain how to create your recommendation. Hang on, let's see if it can create a can you show me an example with a sketch? Oh god, I can't spell. SketchUp file. Not able to create or send directly, I can guide you through creating a basic dovetail joint. Use a rectangle to draw 2 panels. 6 minutes. Set the size of the panel to your preference. Let's assume you use 100 by 100 panels. You should have 2 rectangles. Create a dovetail slot in panel 1. Select the push-pull to extrude. Right, I'll tell you what I'll do. Right, so I'll take this off screen a minute so I can follow it while I'm working. Right. Let's leave that alone a minute. Right, let's create 2 panels, 100 by 100. 2 rectangles, 100 by 100 panels. Create. Select the push pull, extrude the first panel to the thickness of 6 mil. Yeah. Okay, so we've got 2 of them. Use a rectangle to draw a dovetail slot on the edge of panel 1. The slot should be angled. You can use 7 degrees to 10 degree angle to cut the dovetail slot. Right. Use the rectangle tool. Draw a dovetail slot on the edge of the panel 1. The slot should be angled. Right, draw a slot. It's crazy. Where do you start from? Left panel. Oh god, it's crazy, man. Draw a dovetail slot. Angle 7 degrees. It's crazy. Nah, it's just, it's crap. It's crap. It's not even it. Can you show me a drawing? Oh, it's doing it in ASCII again. Maybe that's the only way it can draw stuff. It's not doing it, is it? No. Stop. Right, a drawing with the sizes, I can't spell, the sizes written nearby the lines, not using ASCII. What have we got here? It's not working, is it? What version of ChatGPT are you running? 4. It is 4. Is there an online dovetail calculator? Several. You can access it here. Dovetail, Woodsmith, jig calculator. Right, let's just try one of these. It's not going, why not? Why won't it click on it? What the hell? The links don't work. Oh. As in not clickable. Right, fair play. You have to drag it kicking and screaming sometimes. Right. No, it's just gone silly. What's it doing now? It's crazy stuff. Right, page not found. Tools. Just a lot of advertising. Adhesives, right. Okay, so we're just gonna have to make our own. We've tried to get some help, but we're not getting any help, so we're gonna have to just forget that idea and just have to create ourselves. Create it ourselves. I don't like the angles, they're a bit too pointy, so we'll have to alter the angles a bit. Let's alter the angles. Let's just grab this one and move the whole thing. Move the whole thing this way. 5mm. And grab the whole thing here. Now they probably won't interlock properly. 5mm. Okay, and they're too long as well. A bit too long, so let's sort them out. Too long, 15mm too long. So I'm not sure I could push that in there, can it? No, can't be pushed, it can be pulled out. So I've got to do it a different way. Let's just make them Oops, wrong one. Let's make them 6mm, as in the 6mm plastic. Right, let's just do this then. We don't need to do all that, do we? No. So what I'm going to do is flatten it out. Oh no, we can't flatten it now, can you? Right, we'll carry on the way we are. Right, let's just do it. Create one of them at least. Okay, just lose this. Okay, so we've got this little bit of. Let's get rid of this lines. Look at it in this mode from above. That's better, isn't it? Better, loses less material. There's less to snap off. Okay, so we want what size have we got here? Let's have a look. 24. Let's have them 20mm. So 20mm. And let's have another one. So we want to go from here. Let's go. So it's 20mm. We want at least another 20mm space. So go 40mm. Okay. Now what does that give us? That looks too much. 24mm. Alright, let's go back 4mm then. Okay. Right, so we've got equal spacing, so that should be the same. So that is what? 16mm. What we got here? 16mm and 20mm, 20mm. We've got 6 point something, but 6mm. That's what we'll have then. That's what we'll do. I'll just reproduce this now. So we'll start from this length here. Copy that out to there. Copy that out to there. Copy that out to there. And copy that out to there. And we'll stop it there. And we'll put a piece in there. Don't want the filler, the paint. Right, so we've got that there. We've got some weird extrusion going on, so we'll just copy the, delete all this. Okay, and we'll just redo it. 6mm. Okay, so we've got that there. There's our piece. Get rid of this one and duplicate that one and spin it round. Oh, keep getting the bucket. Right, I'll try and lock it in position by dragging it from there to there, just like that. Okay. Something doesn't look right. unless it's just the way I got it selected. It is, isn't it? Just the way I got it selected. And you could flip that over the other way, then it won't not fit. Doesn't matter. Anyway, so we'll have to implement that across the stitching. So we're going to put the two panels together, so you could basically make these bigger, say 300, 300s. Right. Okay, so we've got let's just colour them so see if what they look like. Where's it gone? Right, and there's this bit here, it's no good. Need to see what it looks like. Okay, so I've got them joining up. This is the same material, so you've got two big panels. There's a stitch in there. What are we looking at? Hang on. X-ray, same thing. Let's turn it on its side. And the other way around. Put it somewhere like I can make big pieces out of this. So you've got a weird stitch going on, dead ugly, but ugly, but it's alright for the base and the lid maybe. You only got two pieces together. We need to make 4 pieces together probably to do this area. So to that end, let's just move this over here a minute. Right, okay, so what we've got to do is go into the edge. That's not right. That's better. So we'll just what we want is to copy this here. Actually, copy all that there. How are we going to do this? So we need a template to copy that to an edge. So what I'll have to do... Oh, I've lost it now. I have to flatten it first, probably. Flatten it back again. I don't know if I'm upside down or what. If I flatten it now, I'm going to have nothing left to work with. So what I've got to do is find the edge on, like that. And just go into it. Grab everything but... I'll tell you what, delete. See if I can do it this way. Hang on. So delete everything there. Oops, what have we got stuff left? Oh, I got you. Right, so we've got that there, so we need to copy this now. I'll just copy that there. Right, so hang on. Copy it, come out, paste it in place, rotate it. I need to rotate it round this angle. So I don't know where to grab it from. Let's try the middle. Oh, that's not going to be any good. We need to move it out the way. Oh no, it's on the surface, that's fine. We need to move it somewhere like this. Needs to be in there though, so it needs to be done from there. So I need to cut it, paste it in place. Right, what have we got here? Is it okay? Just got a thin piece at the minute. Ah, we still haven't pasted it. We're not in the model yet. There we are. Paste in place. That's it. So get rid of. Right, we need to move that over there. So that needs to stay there. So it needs to finish on one of these. So I need to push that out to there. Sort of. Okay, there's a bit of a weirdness going on there, but hang on. We'll have to come up with a design that works. No, wrong one. Right, okay. Suppose we could copy that out. Start from there. So we want same again. Have one more. How do we get that? God knows. There's more to this dovetailing that meets the eye, isn't there? So that doesn't look right there. So we can't have a dovetail on the edge like that. So we need to sort that out. So we need to move that over to an amount 12 mil. No. Oh yeah, I could do that 12 mil. I'll just correct this after. Right, so we've got that there. So we've got a line. We need to keep the corners intact. Right, which means we need to spread that over. Yeah, that's right. We need to bring that back. Bring that back to there. Get rid of this bit. So we've got a weird arse corner. It seems to be too long. So we've got 12 mil there. Ideally we want to be spaced apart, so that's 20 mil. We've got 12 mil. Already we just want 10 mil. So let's move it up. Move that up 2 mil. Okay, so that gives us our 10 mil. Yeah, and we want 10. We got what we got here, 20 mil. We need to bring the whole thing back by 10 mil. Right, I know it's too thin there. That'll snap off. Yeah. So we need to start 20 mil. So we basically need to go back out to 20 mil and then to bring this down by 10 mil. That's better. So it got some, nothing going to snap off now. So that's what we want, and we've got ourselves a corner, and we've got what we got here, 20 mil and 20 mil. That's probably best. Okay, and the problem is we'll end up with weird sizes. So one of these where it joins might have to be a weird size to make up for that. So let's make let's copy this over to here. Right, so we've got weird ass stuff going on here. Right, okay, so yeah, one of them's got to join in there. We basically got to make it like a Lego, so each part joins up to the next part. There will have to be some compromise based on the size. So that's weird there, so right. What size have I got here? I don't know. Can't remember what I did. 200 mil. And what we got this way? 361 mil. That's too wide anyway. So what we want is we want to do it at 300 mil. No. What didn't I do? Hang on. So that's there. So, Anyway, that'll do for testing. So we can get rid of... Oh, that's already a component of this one. Oh, God. I've been drawing this upside down all this time. Let's bring it out. And join it up. So we can join it that way. Now, problem is these aren't... I've got no surface, so I need to make a surface. That's the surface. I need to... Oh, will it let me twizzle it round? 6 mil. There we go. I lost all the colours again now. And I've got weird ass stuff going on here. Right. I make sure I haven't deleted my model. Sides. Yeah, looks all there. front. Let's put everything back on so don't lose everything. Make sure it's easy to lose stuff, especially when you're trying to model within another model. Right, where's the lid? Where's all this stuff gone? Full size Zora slots. Okay, is that the lot? And what we haven't got is a compact flash card sat on the top. We said we were going to get one on the top. Okay. Whatever, right. Okay, anyway, went off on a tangent there. Yeah. What time is it? So, this is ugly. Ugly method. How can I select all that? Can I select all that now? No. Can I go like this? Maybe. Will I lose all the edges? Possibly. Yeah, it's almost invisible. So there's no edges. So the only other way of doing this is to flatten it. Flatten it first, and we know how to do that by, oh god, here we go. Oops, what am I looking at? Yeah, we could do it that way. Alright, so delete that, and then colour it the colour after, and the other side. Okay, and then come out of that, or extrude it 6mm. That's it. Saves going around the whole thing all over again. Shortcut. Right, so we've got our panels locked together. What we want is another one. Something like this. Okay, so we could lock them together and then apply some kind of glue, acrylic glue, so we could build our panels up like that, or don't glue them, just hopefully they fit together with such a tight fit that they don't move, maybe. Anyway, so I'll keep one of these as an example. So that's 6mm, so got from there to there 6mm, which is the same thickness as it. Right, let's bring it back up to the right way around. So we could stitch these together then. So we'd have to stitch these two panels together here because they get them in the laser. Stitch these four together. Stitch the bottom together. But if we did stitch it together, now we'd still need 4 lots though. So we still need to make a base because we've got to attach the sides to it. The sides have got to be attached to it as well. Unless we dovetail the sides to it. Can you dovetail an angle that way and upright? I'm not sure if you can. No, how to do an angle. So, well, they do it on drawers, don't they? They do it on drawers. I need to learn some old skills. Let's just go back into this mode a minute. So if we get a piece of this, for instance, copy it. We need to turn it on its side. Like that. And grab it down here and shove it over there. Right, what have we got going on here now? Totally at odds with each other, look. So you could do it if they weren't dovetailed like that. So how the hell would you do that then? How do they do them on a drawer? Not sure, let's find out. Drawer dovetails. Right. Okay, so one's angled one way, so oh, I see. I see. It's a very clever design, isn't it? There's an example of a wider one. What are we looking at here? I need an example of one. So there's no big pictures, is there? Well, can't we zoom in? Round ones, there's all sorts. Let's see if anyone dovetails acrylic 90 degree. Right, what have we got? Anyone else already done it? Anyone's dovetailing acrylic sheet. No, that's extruded. There's a dovetail milling bit, right? Okay. Somebody's done that weird. Look at that. Bloody hell. Etsy store rounded. That's obviously been CNC'd, isn't it? Nice. It's alright for joining flat. So we've got this idea. That's an angle straight on. So it's like toroidal kind of thing. What do they call it? Can't remember now. See, I could laser that shape out, but I can't laser this shape out. With that line flat, I can't laser an angle. It's got to be straight cut, so you can't have that kind of thing with a laser. So to that end, I could join the ends up, but I'd have to have straight fitting ones. straight fitting, so we'd have to create some straight fitting edges. Just have straight and the fingers would sit together, but then you could still glue them if they were tight fit, but then how would you lock them in? Going back to my other idea, well, the case idea where they fit inside there, the bits stick up inside a hole with a bit of clearance. Here, so it allows you, they're not that big, but they're not spaced. That's only for the lid. Do the same idea for this bit here. Same idea on this bit for dropping these together, so the back could fit into the base. So you could use that idea down here on the back. You could have to bring the base out and then dovetail that to slot in. And we've got these. Actually, if we did that, we could get rid of these fixings and one of the layers of plastic. But then, would it be strong enough? I suppose if it was acrylic cemented, glued. I've got to make sure it doesn't burn the plastic. It's special cement for acrylic, I suppose. But he said ChatGPT said it does melt it. That's how it glues it. So, anyway, it's almost entirely redesigned. Right, so yes, you can join panels like this. So let's just get rid of these a minute. What time we got now? 2.5 hours, right? So we've explored a few ideas. So we got all the sizes now. We got all the dimensions, which take time. So we've got all that capability. Now there is a problem with this CD-ROM. I milled it out in a weird way. Now it looks alright there. Now this piece, when I look at it from there, it's offset slightly. And come to think of it, now it does look offset. So when I hold it up against the real one, just hold this up against the real panel. Let's have a look. It's wider. That's sort of centre on the floppies, but then we're out by about 5mm. The indicator panel's fine, but we're over by 5mm. Yeah, we seem to be 5mm out, possibly more. Yeah, no, we're definitely 5mm out, and it doesn't look centre. Yeah, it looks narrower there than it does there. So even on the drawing, let's just measure this. If we go from here down to there, hang on, I need to go that way. Sorry, I need to go that way. 27.25. And we've got here 32.25. So we're about 5mm out. But if I move it over 5mm this way, we're going to be 27 point size this size. So let's have a look. What happens what happens to the design if I've got to move the whole shelf over? Smooth the sides a minute and the lid. I've got to move the whole thing over. Let's have a look in this. Right. The drives are in the right place, but the CD-ROM is in the wrong place. Needs to shove over this way a bit. Just needs to come this way. So if we needed to do that, what do we do? It's sort of centered in position there. Hang on, what is going on here? Let's have a look. That's 22 mil. And this is what? 27 mil. So we're 5 mil out. We're actually 5 mil out. So that's weird, isn't it? So that whole thing needs to come this way, 5 mil. And then this would have to come that way, 5 mil. And then you have to move these shelves over 5 mil. It can be done easy. Right. So it begs a question on the real one. Let me just measure the real one. Are they equally spaced out on the real one? Let's have a look. So you've got from there to there 30 mil. From there to there 30 mil. So it's equally spaced out 30 mil. So it's 30 mil. It should be 30 mil from there to there. That's 27.25. And from there to there, it's 32.25. So the whole thing needs to go over, I don't know. If I was to grab, so if I grab that, for instance, grab that and move it over 5 mil. That's going to be too much this side now. 32.5 that way. .27. So I've moved it over. So it needs to move over 2.5 mil, doesn't it? So it needs to go 2.5 mil. So we're 2.5 mil out for whatever reason. 30 mil there. 30 mil there. So that's spot on. What about the level, the distance between the two? Let's try that next. Try that next. Looks a bit low, really. Yeah, it's a bit low. So that's there. Looks a bit low. A bit low. It's a bit low, but it hasn't got to be exactly the same. Almost exactly the same. It's a little. It's about a mil and 2 mil out. Needs to go up a mil. Really. Anyway, we'll leave that where it is. So that's thrown that out a bit. And the hole is too low on that other one. So these seem to be okay. So what do we do about that? And it's the same thing here, isn't it? So yeah, we need to go into this. Go into this and move the whole. The drives can stay where they are, but these need to move, and probably the whole thing needs to move over that much if you want to keep those the same, which they are. So we'd have to take that, and that, and move it over. Move it over 2.5 mil. And go into this and move the holes over. .5 mil. And come out, and it should have the same size here. 24.5. 24.5. The rest can stay where they are. So that's okay. Now that should be lined up with the CD. Oh, the rivets are in the wrong place now. Are they? Yeah. Are they? Yes, they are. Okay, so I need to move them over. What are these things here? They're the holes? Yeah. So they need to be moved over. .5 mil. There we go. Yeah, that's it. Okay, so because we've moved all that over, everything else has gone with it. Now the power supply stayed where it is, so that's not right. So that needs to move over as well. So I need to get that and that. All the fixings. And move that over 2.5 mil. Alright, for some reason it looks like it's sticking out. Oh, it does stick out, fair play. I need to, oh yeah, it does, it's supposed to stick out. Right, so I've got that there, that looks okay. Alright, so we've moved all that. Paint, I don't want to paint. Right, so we've got that back to where it's supposed to be. Now the shelf won't be right anymore, the back shelf. So we're going to have to alter, let's alter that. Need to alter that over 2.5 mil. Just like that. And we need to alter, what else? Let's remove the power supply. Where's it gone? Can't see it for looking. Can't see it. Where's it disappeared to? Drive assembly. So move the drive assembly. Let's just save it a minute. Now going back now, we saved it. Right, so this thing is, yeah, we've got to do this inner piece. That's got to be moved as well. 2.5 mil. We haven't altered the height, so now this whole thing here, this has got to be moved over 2.5 mil with the fixings. That's it. Then we've got to move the holes, and that will have to create the G code all over again. Oh well. .5 mil. Right, what's next? Okay, so we've got that back to where it's supposed to be. So that's it, isn't it? I think. Nothing else. Oh, these will have to be moved. Let's just make sure the back's okay. Put the drive shelf back in. Is it okay? It looks okay. Yeah. Are we touching anything? No. No, we're okay. It's a bit tight there now. It's okay though, just about okay. Just about okay. We've got a bit more clearance this side for whatever reason. Right. What's left? Now these bits are touching here now. So we need to push these over. This will be easy. That needs to go over 2.5 mil. This needs to come out 2.5 mil. Okay, so that's good. There's another one to do, the inner bit. Same again with this one. Unless that's the one I've already done. Is that the one? Hang on. Let's make sure that's not the one I've just done. Right, I could do just go like this. X-ray. Bloody hell, what have I got the paint bucket for? Anyway, I can't tell. There's too much going on in the drawing, so let's go back to what we had before. So that's the one I've done. No, that's the one, the outer one. So we need the inner one. We might be able to get rid of some of this soon. 2.5 mil. Might be able to simplify this design if we're going to do stitching. Oh, I've gone the wrong way. Right, okay. Let's just have a look. Drive assembly off. They should be flush there, and then they should be flush over here. Yeah, they are. Okay, so if I put the CD-ROM on, drive assembly, that should all be lined up now. No. CD-ROM hasn't moved, has it? What's going on with the CD-ROM? Oh, it's, yeah, we need to move the CD-ROM over now. That needs to go over by 2.5 mil. That's it. Okay. So we're back again. We've corrected a problem. Now this is a little bit, this window's a bit lower than what it should be. but we'll leave it where it is. I'll leave it where it is, yeah. Okay. Right, so we're ready, we're caught up. We're ready to knock it on the head. So, yeah, we've got a way of doing it now, stitching. Now the biggest problem is this panel. It's going to be stitched. Now, do we stitch it? We've got to stitch it down the middle. We can't stitch it long ways because we still can't make these bits. Unless we CNC that out. But that's the bit you want to see that looks to look the best. Or you could always send it on to an online service and get them to make that piece for you on their proper laser machines. Just that piece, and you make all the rest. You make all the rest, maybe. Or you got the option for both. You need the option for both. Alright, back in a second. Right. Okay, so right, sides, lid on and sides on. So I'll have to ponder over that for a bit, I think. So we've got two lots of acrylic front with, actually that's going to be changed now, isn't it? So if I drop that off and put this one on, all that's going to be out as well. But this one, it's been a while since I looked at this. It's out anyway for some reason. Yeah, I must have lifted the whole thing up and the cross. And do they line up? No, they don't even line up anyway. So, yeah, we'll have to mod that back again. Well, we know what we've done with it anyway. It's got to match that. It's got to lift the whole thing up. We should be able to do it because we know what we've done with it. Let's try it. So go into this. Actually, the whole thing's out by a certain amount, probably 6mm. Let's raise it up by 6mm, but when it's all part of that anyway. It's got the screws with it, so let's go up 6mm. See if that cures our problem out there. Does that cure it? No. Maybe it wasn't 6mm then, maybe it was 3mm. Was it 3mm? No. Don't know what's going on there. Oh, it's whatever this size is here. It's whatever that size is there. Oh, I can't see it in this mode. Whatever that size is there. 4mm. So up 4mm. Okay, so that's brought that right. Fixing holes, sides off a minute. They lined up, yeah, they seem like, hang on, 3D. Yeah, that's sort of lined up now. Okay, so we've sorted that bit out. Now, the only thing we've got to sort out now is what we've done to this bit. So we're just going to go like that. and move this whole thing up by, I can't remember how much it was. Was it 3 mil? Can't remember now. Oh, it was 2.5 mil, wasn't it? 2.5 mil, so 2.5, and that should line it all up. Yeah, because we've got an extra piece. That's it. So that's that one. And if we turn off that one and switch on that one, they should all be the right, but it's in reverse, so it doesn't matter. We don't really use that one. So to that end, we could create the split up sections in the different. So we got the option of both. We just switch on the stitched up areas. So say for instance, let's get rid of the flop. Let's put that mode back on. Side the floppy disks. Where are they? They're in the way, aren't they? Where are they? Where's them floppy disks gone? There. What's this? Compact flash? Is that compact flash? No, it's on layer 0. So I'll put that with a floppy disk layer. Floppy disks, where are you? Can't find it. It's gone. Floppy. No. Floppy disk. That's it. Hide that away with the floppy disk. That's fine. Right, so we've got that there. Can hide the keyboard a minute. Right, so we'd have to stitch this. You couldn't stitch it there because that'll be too weak, so you'd have to stitch it all the way down. So you'd have to come over from here. I can go to 300. So I can go to 300 about there. So it's not all together. I think you can go to 320 if you stretch it out. So that's how much I can fit in the laser. So what would you do? How would you do it? Just glue it and see a zigzag? Don't know. Or get a sticker made. Use the clear polycarbonate, stitch it, then put a sticker over it. I'd get a sticker made at Sticker Mule or something like that. And you can have all the logo done and the graphics, the livery. Just stick it on. You could make it look like quite professional looking. You still have the plastic. Then you'd only see a little bit of a split there before the zigzag. So that's a way of doing it. The front panel at least. Now how would you do this piece here? How would you zip that together? There's not much on it. So that's on an angle anyway, so you could probably, let's have a look what that's like inside. So that's like that, so there is a bit of space. Is there space this side? Don't know. We'll have to look at that again. Anyway, I need to go to the toilet, so that is gonna be it for today. We'll leave it at that. We'll just stick everything back on again for the minute, just so we can. Where's the floppy disk? Right, we'll stick everything back on and we'll come back to it. We'll come back to it. When you zoom in and then you want to switch it off, That'll do. Okay, that's going to be it for today. So I'm going to ponder over that overnight. Thanks for watching. I'm out of here. And here's your outro.
The art of computer graphics is only in its infancy. Only by computer could they be calculated and for the first time pictorially described. The entire musical score accompanying this film was composed on a computer that can produce nearly endless variations of sounds.